Let me start by saying that here we're facing, two narratives. The first one is a techno-optimist narrative, which tells us essentially that the digital transition, the fourth industrial revolution, and climate change mitigation are coupled. And we have, on the other hand, a techno-pessimist narrative, which is essentially telling us that we shouldn't table and bet everything on technology to solve all problems. So we're going to start with a techno-optimist narrative, which essentially is about saying that the whole spectrum of the fourth industrial revolution, including digitalization, big data, the Internet of Things, and so on, is actually supportive of climate mitigation policies and wider ecological transition policies, including the circular economy and biodiversity. And to be honest, there are many examples where probably this is the case. For example, in the energy system, it is essential that we develop demand management techniques, which are evidently much easier to roll out and to attain with fourth industrial revolution related technologies, big data, the capacity to track energy consumption in real time, and so on. It's also much easier with these technologies to decentralize energy systems in an efficient way. If we take the example of transports, it's also evident that the fourth industrial revolution could, in theory, allow us much more easily to develop shared transport models, for example. If we move then on to industrial policy and wider industrial processes, evidently we can have a lot of efficiency gain out of what is called industrial symbiosis, which is essentially circular economy models where one industry's outputs in terms of waste are related to the inputs of other industries, and so on and so forth. So there are many, many different applications of digitalization, of big data, and so on, that could allow us, in theory, to create more efficient processes. That is valid for industry, for the energy system, for transport. It's also valid for agriculture, if we think about precision agriculture techniques, and so on and so forth. So, if you believe that story, essentially, there is a kind of techno-optimist narrative whereby, these two revolutions, so the green, what we could call the green revolution, and the digital transformation are intimately coupled. However, we can also discuss the other side of the coin, which essentially presents a much more nuanced picture. Well, here we get into the more skeptical side of things, which I was mentioning earlier. Because we need to debunk a few myths around digitalization and dematerialization, if you want. Because in reality, a lot of these technologies, although they seem immaterial to us, and are based on a cloud system or on a complete digital basis, are far from dematerialized. In reality, they are extremely dependent on natural resources, on material inputs of minerals, etc., etc. And if we look at the entire spectrum of the supply chain, evidently a substantial part and a growing part of carbon emissions, notably, are emitted as a consequence of digitalization. Now, that's not something we immediately see because you need a life cycle perspective essentially to capture all the spectrum of impacts. However, we do know that as a consequence, notably, of digitalization, there's going to be an exponential growth in the demand of a lot of materials, which implies mining and so on, which then implies impacts on biodiversity and even carbon emission impacts on the supply chains. Now, this is not to say that, if we didn't have digital technologies, we'd have lower emissions, because evidently, these technologies are replacing previous processes that were also linked, to carbon emissions. But we shouldn't make the mistake of thinking that somehow, these things are detached from a material basis. And we can think of many examples where this is the case. And therefore, if we look at the whole spectrum, we can say that by definition, the fourth industrial revolution and the climate transition and the environmental transition are necessarily coupled in a positive way. There are also negative impacts, and we need to start thinking about those and addressing those. Unfortunately, this discussion follows, if you want, the climate transition discussion. That is, we've focused a lot on the co-benefits, if you want, but we haven't focused enough on the negative externalities of these developments and what they imply in terms of future strategies, for instance, to reduce the material throughput which is implied by the digital transition. Well, these expressions are about very different things. I mean, each one of those, is about essentially, again, the coupling between the digital transition, innovation, and the green revolution, on the other hand. But I think, especially the term digital sobriety is a very interesting one because it puts us in a different discussion. The term digital sobriety is essentially about saying that the rollout of new technologies is not inherently good. And that actually, if we think about it in terms of environmental limits, there are many applications of new technologies that are extremely useful for the green transition, but there's also a lot of waste. In the economic system where we live, in essence, any feasible technology will be developed by definition as long as there is a profit to be made. That doesn't necessarily respond to social needs or is attuned with a world in which we need to live within limits. So the question then becomes, where should we use these technologies and how, rather than assuming that by definition they should be rolled out everywhere and we should digitalize everything without thinking of the ends. What is the means and what are the ends? And here there are very interesting takes, I think, mostly from philosophers, actually, around the fact that the digital transition is not a goal. It is a means to achieve potentially higher well-being, to achieve social or environmental goals, but it doesn't entail an end in itself. Whereas in reality, in the current economic system, innovation, for example, is always presented as an end in itself, to which we should aspire. Now, one thing to note as well is that if you want, we can talk about it later, but very often there is a very narrow definition of what innovation means. We very often think about innovation as techniques, as technology, but we don't think enough of innovation in the sense of policies, potentially, or social organization modes in which these technologies can be embedded. Okay, there are a series of things here. So the first thing is related to what I was saying before, that new innovations and digital innovations in particular can be applied in virtually anything. They can be applied in what we could call, socially not very useful activities. They can be applied in socially or environmentally useful activities, and so on. So the question of where we use these technologies and how is essentially requires policy steering. So this is the first thing I would say. The second one is that an aspect which is very often disregarded, and again that I mentioned earlier, is the question of resource use. We're very often focusing, on the carbon benefit effects of a series of policies and so on. Or a series of technologies, and we've seen massive, gains on that front. For instance, the huge collapse of prices as a consequence of technology innovation of renewable energy sources, etc. However, on the back of that, we also know, and all forecasts show that we're going to have a huge increase in resource demand over the next 30 to 40 years. And therefore, the question of circular economy processes becomes extremely central and is increasingly acknowledged as well by the European Union's strategy. So what we need there is essentially, to very sizably increase the percentage of raw materials that can essentially be recycled, not as virgin material throughput, but actually be reused in the productive system in a more circular way. This is definitely something which is a huge stake over the next 30 years. And I should say that we're extremely behind on that, because right now we're talking about, very high-end innovation and reuse and circular designs, etc. But on the other hand, even on the basics, which is, say, recycling infrastructure, countries like Greece, for example, are extremely behind. Therefore, I would say that, and this is, I think, a point we can take, we are very often waiting for technology to change things, or to reach, we're waiting to introduce cutting-edge technologies to solve a lot of the environmental problems, whereas actually we can do a lot already with the existing technologies. And that requires more policy innovation, I would say, and social innovation. So how do you essentially diffuse, existing innovations within, the economic system, the energy system, the waste management system, rather than creating cutting-edge digital platforms and applications, etc., etc. And this is something, I think, which is crucial and is often disregarded. In the energy system, for example, we know that right now, we don't need necessarily more digital infrastructure to decentralize our energy systems. For example, installing PV cells on houses or creating cooperative forms of energy, etc. All these are things that already exist in a number of countries and even in Greece. But the problem here is a matter of scale and rollout, if you want, at a national level, taking from the local and expanding it, rather than a technology innovation issue in the classical sense of the term. So I would say that there are many different levels. One level is thinking about how we can create more and better circular economy models. There is an issue of diffusion of innovation, but there is also an issue of designing innovative policies and harnessing existing technological system rather than waiting for some new future innovation to save us as a deus ex machina. A final comment I will have is that going back to the notion that some economists have formulated, the notion of mission-oriented innovation, among others mentioned by Mariana Mazzucato and other economists. The question we are facing here is that we need to subordinate, if you want, innovation policies, technological evolutions, and so on, to attaining specific social and environmental goals. If our mission is to prevent a catastrophic climate collapse, catastrophic biodiversity loss as well, which is often disregarded, these are very specific missions, and we should subordinate all instruments that we can use. And this evidently includes innovation policies, it includes technology, it also includes new forms of organization, of social organization, of policy innovation to those goals. I think the problem we're having now is that, as I mentioned before, essentially, technology is being rolled out horizontally, and it can have very useful applications to meet environmental goals. But if you want, it is not politically steered in a direction where first its potential is maximized and is blended as well with other dimensions such as finance, such as social innovation, and so on. So I think if there is a lesson that we need to draw, is specifically that we need missions in order to essentially create a roadmap whereby we put our energy, our resources, our creativity, our innovation to meet these social targets. Spoke about environmental ones. There are evidently also social targets. There are health targets. We're still in the middle of a pandemic. But evidently, within this whole frame, a lot of social goals can be inserted and met.